In this lesson, we will discuss how to solve a system of linear equations by graphing. We will work through different examples, starting with equations given in standard form, and then in slope-intercept form. Finally, we will see two special cases, one where the system of equations has no solution, and another where it has infinitely many solutions. The first step in solving a system of equations graphically is to plot the graph of each equation. In this example, both equations are given in standard form, and the most straightforward method for graphing such equations is the intercept method. So, we will start by finding their x-intercept and y-intercept. Let's begin with the first equation. The x-intercept occurs when y is 0, so replace y with 0 and solve for x. 2 times 0 equals 0. So we are left with 3x equals 12. To isolate x, divide both sides of the equation by 3. Cancel out the 3's. 12 divided by 3 is 4. Therefore, the x-intercept of the first equation is 4, 0. The y-intercept occurs when x is 0, so set x to 0 and solve for y. 3 times 0 equals 0, and we have 2y equals 12. To isolate y, divide each side of the equation by 2. Cancel out the 2's. 12 divided by 2 is 6. So, the y-intercept of the first equation is 0, 6. Now, let's find the intercepts for the second equation. Replace y with 0 to find the x-intercept. 2 times 0 equals 0, and we get x equals -4. So, the x-intercept of the second equation is -4, 0. Set x to 0 to find the y-intercept. Divide both sides by -2 to isolate y. -4 divided by -2 is 2, giving us the y-intercept 0, 2. Now that we have our intercepts for both equations, the next step is to plot them on a graph. For the first equation, plot the x-intercept, which is at 4, 0, and the y-intercept, which is at 0, 6. Then connect the 2 points with a straight line. This line represents the first equation. For the second equation, plot -4, 0, which is the x-intercept, and 0, 2, which is the y-intercept. Then, connect them with a straight line. This is the line of the second equation. The intersection point of these two lines, which is 2, 3, is the solution to the system of equations. We can verify this solution by substituting it into both equations. Substitute 2 for x and 3 for y. In the first equation, 3 times 2 is 6, and 2 times 3 is also 6, which adds up to 12. In the second equation, 2 times 3 equals 6, and 2 minus 6 equals -4. As you can see, both equations are satisfied, confirming that the order pair 2, 3 is indeed the solution. Now, let's solve the second example where the equations are given in slope-intercept form. To graph an equation in slope-intercept form, the most straightforward method is to use the y-intercept and the slope. So, the first step is to identify these values from the equations. For the first equation, the y-intercept is at 0, -2, and the slope is 1/2. For the second equation, the y-intercept is at 0, 1, and the slope is -1. Now let's begin by graphing the first equation. First, plot the y-intercept, which is located at 0, -2. Remember that slope is the ratio of rise over ran. Since the slope is 1/2, the rise is 1 unit up, and the ran is 2 units to the right. Now, starting from the y-intercept, go up 1 unit, then move to the right 2 units. Plot this as the second point. Let's plot one more point. Starting from this point, again, go up 1 unit and to the right 2 units. Then, plot this as the third point. The advantage of the slope-intercept form is that we can easily plot more points and make our graph more accurate. Next, connect the points with a straight line. This represents the line of the first equation. Now, let's plot the graph of the second equation. As we did before, we start by plotting the y-intercept, which is located at 0, 1. Its slope is -1, which is the same as -1/1, right? So, the rise is 1 unit down, and the run is 1 unit to the right. Starting from the y-intercept, go down 1 unit, then move to the right 1 unit. Plot one more point by moving from this point, 1 unit down and 1 unit right. Now, connect these points with a straight line. This is the line of the second equation. The intersection point of the two lines is 2, -1, which is the solution to the system of equations. If you have any questions, please feel free to leave them in the comments below. Now let's consider the two special cases. What method do you suggest to graph these equations? The first equation is given in slope-intercept form, so you can use the y-intercept and the slope. While the second equation is given in standard form, so you can use the intercept method. The y-intercept of the first equation is the point 0,5, and the slope is -4/3. As we did in the previous example, we will start by plotting the y-intercept, which is located at 0,5. Slope is rise over ran, and in this case, it is -4/3. You can place the negative sign in the numerator. It will not change the value of the slope since they are equivalent fractions. The key concept to remember is that when the rise is positive, we move up, and when it is negative, we move down. In this case, since the rise is -4, we move 4 units down. Similarly, when the ran is positive, we go to the right, and when it is negative, we go to the left. In this case, the ran is +3, so we go 3 units to the right. Now, starting from the y-intercept, move down 4 units, then move to the right 3 units, and plot the second point. Let's add one more point. Starting from this point, move down 4 units, and move to the right 3 units, and plot the third point. Then, connect these points with a straight line. Now, let's move on to graphing the second equation using the intercept method. First, let's find the x-intercept. Set y to 0 and solve for x. 3 times 0 equals 0, so we are left with 4x equals -12. Dividing both sides of the equation by 4, we get x equals -3. So, the x-intercept is -3,0. Next, let's find the y-intercept by setting x to 0 and solving for y. 4 times 0 equals 0, and we get 3y equals -12. To isolate y, divide both sides by 3, giving us y equals -4. Therefore, the y-intercept is 0, -4. Now, plot the x-intercept, which is located at -3,0, and the y-intercept, which is at 0, -4. Then, connect these 2 points with a straight line. Notice that the 2 lines do not intersect, they are parallel lines. If the lines of the 2 equations are parallel, then the system has no solution. Finally, let's consider the case where the system of equations has infinitely many solutions. Please feel free to pause the video and give it a try. The first equation is given in standard form, so first, we will find its x and y intercepts. To find the x-intercept, set y to 0. 5 times 0 equals 0, and we get 2x equals 10. Divide both sides by 2 to isolate x. 10 divided by 2 is 5. So, the x-intercept is 5, 0. To find the y-intercept, set x to 0. 2 times 0 equals 0, and we have -5y equals 10. To isolate y, divide both sides by -5, giving us y equals -2. Therefore, the y-intercept is 0, -2. Next, plot the points on the graph. Plot 5, 0, which is the x-intercept. Plot 0, -2, which is the y-intercept, and then connect them with a straight line. Moving on to the second equation, which is in slope-intercept form. The y-intercept is at 0, -2, and the slope is 2/5. Start by plotting the y-intercept. Slope is rise over ran, and in this case, it is 2/5, which means the rise is 2 units up, and the ran is 5 units to the right. Starting from the y-intercept, move up 2 units, then go to the right 5 units, and plot the second point. You have likely noticed that both points lie on the line of the first equation. When you connect these points with a straight line, it perfectly aligns with the first line. So, the line of the first equation and the line of the second equation are the same. They coincide perfectly. If the lines of the two equations are coincident, then the system has infinitely many solutions. This means that any point on the lines satisfies both equations. In conclusion, when solving a system of equations graphically, first graph each equation on the same coordinate plane. If the lines intersect, the point of intersection is a solution to the system of equations. If they are parallel, the system has no solution. If they are coincident, the system has infinitely many solutions. Thanks for watching. If you found this video helpful, please give it a thumbs up and subscribe.